Visualizing data in Python using plt.scatter. An important part of working with data is being able to visualize it. Python has several third-party modules you can use for data visualization. One of the most popular modules is Matplotlib and its submodule, pyplot, often referred to using the alias plt. Matplotlib provides a very versatile tool called plt.scatter that allows you to create both basic and more complex scatter plots. In this course, you'll walk through several examples that will show you how to use the function effectively. You'll learn how to create a scatter plot using plt.scatter, use the required and optional input parameters, customize scatter plots for basic and more advanced plots, and represent more than 2 dimensions on a scatter plot. To get the most out of this video course, you should be familiar with the fundamentals of Python programming and the basics of NumPy and its ND-array object. You don't need to be familiar with Matplotlib to follow this course, but if you'd like to learn more about the module, then check out Python plotting with Matplotlib. So now that you know what you'll be covering, let's get started. Creating scatter plots. A scatter plot is a visual representation of how 2 variables relate to each other. You can use scatter plots to explore the relationship between 2 variables, for example by looking for any correlation between them. In this section of the course, you'll become familiar with creating basic scatter plots using Matplotlib. In later sections, you'll learn how to further customize your plots to represent more complex data using more than 2 dimensions. Before you can start working with plt.scatter, you'll need to install Matplotlib. It's generally a good idea when experimenting with new Python code to do so in a virtual environment, and if you're not sure how to do so, check out this Real Python course. Matplotlib can be installed using Python's standard package manager pip by running the following command in the console. Now that you have Matplotlib installed, consider the following use case. A cafe sells 6 different types of bottled orange drinks. The owner wants to understand the relationship between the price of the drinks and how many of each one he sells, so he keeps track of how many of each drink he sells every day. You can visualize this relationship with the code that follows. In this Python script, you import the pyplot submodule from Matplotlib using the alias plt. This alias is generally used by convention to shorten the module and submodule names. You then create lists with the price and average sales per day for each of the 6 orange drinks sold. Finally, you create the scatter plot using plt.scatter with the 2 variables you wish to compare as input arguments. As you're using a Python script, you also need to explicitly display the figure using plt.show. If you're using an interactive environment such as a console or a Jupyter notebook, you won't need the call to plt.show. But in this course, all the examples will be in the form of scripts and will include that call. Here you can see the output from the code you've just seen. This plot shows that, in general, the more expensive a drink is, the fewer items are sold. However, the drink that costs $4.02 is an outlier, which may show that it's a particularly popular product. When using scatter plots in this way, close inspection can help you explore the relationship between variables. You can then carry out further analysis, whether it's using linear regression or other techniques. For more on linear regression, check out this Real Python course. You can also produce the scatter plot shown above using another function within Matplotlib's pyplot module. plt.plot is a general-purpose plotting function that will allow you to create various different line or marker plots. You can achieve the same scatter plot as the one you obtained in the section above with the following code. In this case, you had to include the marker O as a third argument, otherwise plt.plot would plot a line graph. The plot you created with this code is identical to the plot you created earlier with plt.scatter. In some instances, for the basic scatter plot you're plotting in this example, using plt.plot may be preferable. You can compare the efficiency of the two functions using the timeIt module. Firstly, timeIt is imported. Then a print statement is included for each type of call, which includes a call to timeIt.timeIt. The timeIt call includes the command to be run, the number of times that the command should be run, and the namespace in which it should be executed. The performance will vary on different computers, but when you run this code, you'll find that plt.plot is significantly more efficient than plt.scatter. When running the example on my system, plt.plot was significantly faster, as seen in the figures on screen. If you can create scatter plots using plt.plot, and it's so much faster, then why would you ever use plt.scatter? You'll find the answer in the rest of this course. Most of the customizations and advanced uses you'll learn about are only possible when using plt.scatter. Here's a rule of thumb you can use. If you need a basic scatter plot, use plt.plot, especially if you want to prioritize performance. If you want to customize your scatter plot by using more advanced plotting features, then use plt.scatter. In the next section of the course, you'll take a look at the customizations that you can only do using plt.scatter. Customizing markers in scatter plots. You can visualize more than two variables on a two-dimensional scatter plot by customizing the markers. There are four main features of the markers used in a scatter plot that you can customize with plt.scatter: size, color, shape, and transparency. In this section of the course, you'll learn how to modify all these properties, so let's get started by looking at size. Changing the size. Let's return to the cafe owner you met earlier on. The different orange drinks he sells come from different suppliers and have different profit margins. You can show this additional information in the scatter plot by adjusting the size of the marker. The profit margin is given as a percentage in this example. You may have noticed a few changes from the first example. Instead of lists, you're now using NumPy arrays. You can use any array-like data structure for the data, and NumPy arrays are commonly used in this kind of application because they enable element-wise operations that are performed efficiently. The NumPy module is a dependency of Matplotlib, which is why you didn't need to install it manually. You've also used named parameters as input arguments in the function call. The parameters x and y are required, but all the other parameters are optional. The parameter s denotes the size of the marker. In this example, you use the profit margin as a variable to determine the size of the marker and multiply it by 10 to display the size difference more clearly. On screen, you can see the scatter plot created by this code. The size of the marker indicates the profit margin for each product. The 2 orange drinks that sell the most are also the ones that have the highest profit margin. This is good news for the cafe owner. In the next section of the course, you'll see how to change the color of markers and include more information on the same scatter plot.